Okay, so we have a pulley system here on an inclined plane, and mass one is sliding up at a constant speed, and there is friction between mass one and the incline. So what we're going to do here is we're going to look at the force diagrams of object one and object two, um, and we are going to determine the mass of object two. So for this, for object two, since it is moving at a constant speed, the forces here will be balanced. So I'm going to have the force exerted by the string and that of the earth on M2. And then over here for object number one, we have the string pulling up the ramp. We have the earth pulling straight down. We are going to have friction that is going to oppose the motion. And we have the normal force that is perpendicular to the ramp itself. I'm going to draw in an XY axis in blue to make it nice and clear. I am going to call the positive direction the direction of motion. And this one, since the acceleration is 0, we're not going to have to worry about the direction of acceleration too much. And I'm also going to draw my components. So this is going to be the components of the earth, and this here would be my angle alpha. All right, so now I have a clear picture of the forces exerted on each object, and since we know the acceleration is going to be 0, setting up Newton's second law, I'm going to have m2g minus the force of the string over mass 2 will equal 0. So ultimately, this will be the force of the string is equal to m2g. For the one on the incline, I'm going to set up Newton's second law in both the parallel to the incline and perpendicular to the incline. Parallel to the incline, I will call my x-axis. Perpendicular, I'll call my y. I have the normal force, and then given where alpha is, it is going to be minus m1g sine alpha is equal to 0 divided by m1. And I got the trig function wrong there. I apologize, that's not sine, that would be cosine. So I have the normal force is equal to m1g cosine of alpha. In the x direction, I am going to have the force of the string minus friction minus m1g sine of alpha. And again, that will equal 0. So the force of the string minus mu times the normal force minus m1g sine of alpha is equal to 0. So what I can do here is now I can solve for m2, that I have all my equations set up, by just making a couple substitutions. I see we have an expression for the normal force, which we can substitute in to the expression for the forces parallel to the incline. And we know the string, which is m2g, can be